Pamela Parra. Today we are going to see a small explanation about a balanced chemical equation. We are going to do some exercise and practice, always using the rules such as not forgetting the plus signs, among others. Okay guys, let's see the exercise. Let's remember the rule to start. Count each atom of the reactant and product side, and the coefficient and the subindex are multiplied. Don't ignore the plus sign. Generally, the coefficient for hydrogen and oxygen and glass assigned. You can add the coefficient in both the reactant and product side. Well, here we have the chemical equation. Now, we are going to separate the atoms on the reactant side, which is the left side. So, potassium 1, chlorine 1, oxygen 3, and phosphorus 4. Now we have to separate the atoms on the product side. Potassium 1, chlorine 1, oxygen 10, and phosphorus 4. Well, let's not forget to follow the rules. Never ignore the plus sign. Multiply the coefficient, which is a large integer, with the subindex, which is a small number. Count the atoms we already did. Something very important, the coefficients in the oxygen and hydrogen are assigned to the latter. We look for a number that is close to balance, and the number 10 in the potassium of the reactant. This number 10 affects the potassium, chlorine, and oxygen of the reactant. As we see, the number 10 was multiplied with the subindex of oxygen, and the atoms change, we can see it at the bottom. The equation is not balanced yet, so in the potassium and chlorine of the product, we put the coefficient number 10. The atoms change, but the equation is still not balanced. We put another coefficient on the reactant phosphorus so that we can balance it as well as the product for the moment. The coefficient is multiplied with the subindex of the phosphorus, but the product is not balanced. Now, we look for a number to balance it, and we put the coefficient 3 in the phosphorus and oxygen of the product. As we know, the coefficient is multiplied with the subindex. And ready balance the equation. Potassium 10, chlorine 10, oxygen 30, and phosphorus 12. Both atoms are the same in the reactant and product. Hi, I am Pamela Parra. Here we have a chemical equation. Now we separate the atoms in the left side. Phosphorus 2, hydrogen 2, and oxygen 6. Now we separate the atoms on the right side. Phosphorus 1, hydrogen 3, and oxygen 4. On the side of the reactant, which is the left side, we have 6 atoms in oxygen because 5 plus 1 equals 6. Now, we look for a coefficient, in this case, the number 2. We place it in the hydrogen of the product. Change all the atoms, because 2 we multiply by the subindex. 2 by 3 equals 6. Phosphorus has 2 atoms and oxygen 8 because 2 is multiplied by 4. Once the product is already there, we look for the coefficient number 3 in the hydrogen of the reactant. The atoms change and we check if it is balanced. If the equation is not balanced, we look for another coefficient. We multiply the same process and realize that the 3 of hydrogen will affect the product. Phosphorus has 2 just like the product hydrogen 6 and oxygen 8, as well as the product, and this equation is balanced.
Good afternoon. Let's practice an example of a chemical reaction. First, let's know what the objective is. The objective is balance both parts of the chemical reaction, reactant and product, according to the rules within the process. The exercise we will solve is the following, in which the following elements will participate: lead, oxygen, hydrogen, and chlorine. Let's begin. The first thing we must do is to classify all the elements in order. First, the lead, then the chlorine, and by the rule it is important to know that the hydrogen and oxygen are placed at the end. Don't forget that the 2 coefficient in the reactant will only affect those in the parentheses. The same on both sides. In the reactant side, we have 1 lead atom, 1 chlorine, 3 hydrogen, and 2 oxygen. In the product side, we have 1 lead, 2 chlorine, 2 hydrogen, and 1 oxygen. We need to balance chlorine, hydrogen, and oxygen. To do this, we add 2 coefficients in the reactant next to the hydrogen and chlorine. Once added, we will change the number of the ranking on the left side. To balance completely, we had 2 coefficients in the product, exactly next to the hydrogen and oxygen, and we change the classification numbers on the right side. Finally, we verify that everything is balanced and we are done. The solution is as follows. Thank you, I hope you like it.
Let's see. Zinc plus hydrogen chlorine equal to zinc chlorine 2 plus H2. What we have to do next is to see all the elements we have and put them in a column. Our elements are zinc, hydrogen, and chlorine. Next, we have to see how many atoms they have. Zinc have 1, hydrogen have 1, and chlorine have 1 in the product, in the reactant part. Now, in the product part, zinc have 1, chlorine have 2, and hydrogen have 2. As we can see, the equation is not balanced because we have 1, 1, 1, 1, 2, 2. So we have to fix that. How about we put a 2 in front of HCl? You may ask, why? Well, it is because if we multiply 2 multiplied by 1, the answer is 2. So H will be 2, as well with Cl. So now we have 1, 1, 2, 2, 2, 2.
Hi, I'm Nicole Ramos. Here we have a chemical equation on the left side. In the reactive, we have 1 atom of sulfur, 2 atoms of oxygen, and 2 atoms of hydrogen. On the right side, in the product, we have 1 atom of sulfur, 1 atom of oxygen, and 4 atoms of hydrogen. Because if we add the 2 atoms that each hydrogen has in the product, it will give us 4 atoms of hydrogen. We can see that the sulfur for the moment is equal in both sides, So for now, this is balanced. The oxygen is not balanced because in the reactive we have two atoms of oxygen, while in the product we have only one atom of oxygen. Hydrogen is not balanced since we have two atoms in the reactive and four atoms in the product. So let's start balancing. In the product, we can put the coefficient of 2 to H2O. If we multiply the coefficient by the number of atoms of the hydrogen, will give us as a result 4 atoms of hydrogen. And if to those atoms of hydrogen we add the other 2 atoms of hydrogen that are in the first part of product, we will be left with 6 atoms of hydrogen in the product. And since the oxygen is next to the hydrogen, this is multiplied by the only atoms of oxygen. Then as 2 times 1 equals 2 in the product, the oxygen is left with 2 atoms. Now let's look at the reactive. In the reactive, we can put the number 3 as a coefficient, so if we multiply the 3 by the 2 atoms of hydrogen, it will give us 6. In this way, we can say that everything is already balanced. Thanks you.
Good morning, my name is Oyaira and today I'm gonna explain you how to balance a chemical equation. So this is a problem we are gonna balance today. The first thing we have to do is write on the side of a paper the number of elements we have. So for phosphorus we have 2. For hydrogen we have 2. And for oxygen we have 6 in the reactant part. Now in the product part we have 1 for phosphorus, 3 for hydrogen and 4 for oxygen. The next step we are gonna do is that we are gonna start balancing. I'm gonna put at number 2 on the product side, like here you're watching, and we are gonna immediately change the numbers that we put before. So P will be 2, H will be 6, and O will be 8. That's because the number 2 is multiplying the 3, the 1, and the 4 coefficients that we have in the product side. The next thing is that we are gonna put a 3 in the reactant part, and our numbers that we wrote are gonna change. P will be 2, H will be 6, O will be 8. And why? Because the number 3 is multiplying the hydrogen with the coefficient 2 and the oxygen with the coefficient 1. And if we saw or compare the numbers that wrote, P is 2, H is 6, and O is 8. What does it mean? That we have balanced this chemical equation. Thank you for your
Here are
attention.
some exercise for you to practice. If you want to pause the video so you can do them. This equation is easy. Let's explain it. We count the atoms of the reactant and product, and we see that it is not balanced. We look for a coefficient. In the hydrogen and chlorine of the reactant, we put the coefficient number 2, and the equation is balanced in a super easy way. First, we count the atoms. We add the coefficient 2 in the aluminum and continue looking because it is not balanced. Now, we add the coefficient 2 in the aluminum of the and continue looking because it is not balanced. The oxygen is last and we use the number 3, but the equation doesn't balance it. Now, in the coefficient of the reactant, we change in the aluminum the number 2 by 4 and the equation is totally balanced. Here, the coefficient 2 was simple added to reactant and the equation was balanced. Never forget the plus sign, please. Thank you for watching. Now, let's practice it again. Are you ready? Reactant, we have 2 nitrogen atoms, 2 oxygen, and in the product, 2 nitrogen and 1 oxygen atom. This chemical equation is not balanced. To balance it, we have to add coefficients in the nitrogen of the reactant. We add the 2 and multiply with the subindex 2 by 2, 4. Now, in the product, we add the 2, we multiply 2 by 2, 4. 4 nitrogen atoms and 2 oxygen atoms by the coefficient. Yes, the chemical equation is balanced. Here there are 1 carbon atom and 1 oxygen atom. In the product, we have 1 carbon atom, another carbon atom, and 2 oxygen atoms because we multiply the coefficient with the oxygen subindex. The chemical equation is not balanced, so we add a coefficient that is number 2 in the reactant carbon. Now, the chemical equation is balanced because we have in the reactant 2 carbon atoms and 2 oxygen atoms. In the product, we have the same 2 carbon atoms and 2 oxygen atoms. Thank you.